Welcome to everyone. It's delightful to see you, and it's a privilege to get the opportunity to share with you this morning the results of new survey work that we've been engaged in now for a couple of months very deeply. I especially want to thank, in addition to Buzz and Debbie Dunn, Meg Caldwell, who made this possible and had a vision of what to do here and inspired us to move in this new direction. Buzz actually is the person who some years ago said to me, you know, climate change is looking increasingly inevitable in ways that will produce effects in our lifetimes. And so moving a focus to thinking about not only mitigation but also adaptation makes sense, and that's what we're doing today. I'd like to begin by just acknowledging a group of principal investigators, the most important of whom is at the top here. Dr. Bo McInnes is affiliated with Stanford, and she is the driving force behind this project. Additionally, Adina Ablis, who is here as well, played a very central role. And we have four folks who are also listed at the bottom of this slide who helped in preparing, and Lauren Howe you will hear from a little bit later. I also want to pause just for a second to acknowledge Robert Sokolow, who's a professor at Princeton University. And Rob actually is responsible for a very important idea that you will hear come up later in this presentation, and I wanted to thank him clearly. So the outline for our presentation today is to tell you about a survey that focuses on sea level rise and storms and the risks that are potentially associated with them. We're going to look first at general attitudes. You could imagine that people might, in the public, having watched, for example, Superstorm Sandy, say, gee, you know, it'd be nice if we could prepare for these kinds of things to reduce the effects that they have. On the other hand, you could imagine people adopting a wait-and-see attitude, where they say, well, we can't know when this will happen. We can't know exactly what to do. We could do lots of things to prepare for events that will never occur. So to get a feel for that, we will explore that at a very general level. Then we'll talk about specific strategies that local, state, county, and federal agencies are considering for possibly reducing the impact of sea level rise over time. And we'll look at which of these policies the public likes, which they don't, and you'll get a very clear sense not only of how the public thinks about what could be done, but how they'd like to see it paid for. And lastly, we'll talk about the impact of science communication. So when scientists talk about their findings on sea level rise to the public, they have various options, various choices about how to express their research findings. And we'll talk about how the choices they make appear to influence the reactions of the public. So the survey I'm going to tell you about is based on a nationally representative probability sample. This means we're using genuine random sampling to give everyone in the United States a possibility of participating in it. There are more than 1,000 respondents in this survey. We interviewed in both English and Spanish, which is increasingly the standard. GfK Custom Research did this for us through the internet with a panel that they developed where they recruited a random sample of American households to participate in regular surveys via the internet, and we're very grateful to them. The data collection is very recent, March 3rd through 18. So let's begin by talking about the basics. What do people see as the fundamentals of the background of this issue? And here's one of the first questions that we asked in the survey. What's your personal opinion? Do you think that the world's temperature probably has been going up over the past 100 years? Or do you think this probably has not been happening? And the number that comes out of this for this particular survey is 82% of Americans saying they believe this to be the case, and only 17% saying they do not see that to be the case. And we will show you this afternoon, if you have time to come to another briefing on Capitol Hill, that this number fits very tightly in with other surveys we and other organizations have done. So Americans, at least in terms of this issue, seem, a large majority of them seem to be accepting the existence of past warming. What about sea level rise? So we have three questions now. These are not the actual question wordings. These are just summaries. First, will global warming cause sea level rise or not in the future? Secondly, would sea level rise caused by global warming be good, bad, or neither good nor bad? And you might wonder, why would we ask a question with the word good in there, since many people can't imagine the idea of the sea rising being a good thing. But you've got to ask balanced questions. You've got to offer people all opportunities, and as it turns out, some people actually select that answer, and so we want them to have that opportunity. And lastly, how serious of a problem will sea level rise induced by climate change be for the U.S., not for the world, but for the U.S. over the next 100 years. I'm going to focus on the top 3 points on our rating scale that are listed there. So let me show you the numbers. First of all, what proportion of Americans think that global warming will cause sea level rise? A hefty majority of 73%. The percent of people who believe that that would be bad is 68%. And 76% say that they believe global warming-induced sea level rise will be a serious problem in the future. So that sets a stage. It suggests that Americans are aware of the scientific literature on this and the possibility that encroaching waters will cause problems. What about storms? Because storms are a very related part of this. Will global warming cause storms to be more damaging in the future? And will global warming-induced increases in storms be good, bad, or neither good nor bad? And what you can see here is that 71% of Americans said that they thought global warming will cause storms to be more damaging, and that 77% said that global warming-induced storm increases will be a bad thing. So again, hefty majorities. Now we come to the question of prevention. Should work be done in order to prevent the effects of this sea level rise? And you can imagine the work being done by the federal government or by coastal state governments. By that I mean the governments of states along the coast, by local governments located near the coast, and by businesses located near the coast. And so we asked people about how much effort each of these groups ought to devote to this. I'm going to tell you about the top 2 points on our rating scale, quite a bit or a great deal. For the federal government, 45% of Americans said that these groups should put substantial effort in. Excuse me, the federal government should put substantial effort. A bit more, 53% for coastal state governments, about the same level, 52% for local governments near the coast, and businesses just slightly less at 48%. So these are, you can say, about half of the country saying that quite substantial effort should be put into prevention by these organizations. Interestingly, let me show you the percent of people who said these organizations should do nothing to prevent. 14% for the federal government, 8% for coastal state governments, 7% for local governments, and 8% for businesses near the coast. So this is telling you about 90% of the country would like to see state, local, and businesses doing these kinds of things. Now, should we, in general, prepare or should we wait? Well, our question was, we described to people 2 options. One option for people and organizations is to wait for the damage to happen and then adapt to it. Rather than waiting, people and organizations could instead do things soon to try to prepare for the damage before it happens. And you could imagine the country leaning either way. And what we see is this. 82% of people said they thought we should prepare and not wait, and only 16% of people said they thought we should wait. Who should pay for the preparation? Again, we asked a question pitting government against people and businesses who would be affected by the damage along the coasts. And as you know, one of the interesting facts about current policy is that the government ends up paying for disaster recovery through FEMA and other devices later when it happens. Do people feel like government should pay in advance as well? Well, the answer is that only 38% of people feel that the government should pay for these prevention efforts, and that 60% believe that people and businesses who would be affected should bear the cost. And as you'll see, it's not that people don't want government involved, but they do want these individuals to pay through a particular taxation mechanism I'll describe to you. Now, you could imagine an argument being made that taking these steps to prevent damage that will occur from sea level rise and storms might be damaging to the economy. If we devote resources to this, it would perhaps hurt the economy, reduce the number of jobs available, and so on. That's an argument we sometimes hear made about climate change efforts more broadly. So we asked, do you think doing things to prevent damage in this area would help, hurt, or neither help nor hurt the U.S. economy, would cause there to be more jobs, fewer jobs, have no impact on jobs? We also asked about the respondents' own state economy and jobs there. We asked about actually, sorry, there's a little typo here, jobs in the town where the respondent lives. And lastly, we asked directly about the respondent. Do you think doing things to prevent the effects of sea level rise would make your life better, worse, or would have no effect? And here are the results. So you can see, first of all, on the left-hand side, that the proportion of people who think that, this is a slide for the nation as a whole, that the national economy would be hurt by prevention efforts is about a third of the country, and only 13% of people think this would cause fewer jobs. In fact, pluralities, 42% and 60%, think that actually doing this work would help the economy and cause there to be more jobs. When we shift the focus now to the state where the respondent lives, you see the same down, up pattern. Here, about 20% of the country believe that the state where they live would be hurt, and 38%, almost twice as many, think it would be helped. Similarly, people are more likely to believe these prevention efforts will create jobs than to cause fewer jobs. And when we shift to your town, you see exactly the same pattern again. Fewer people believe there would be help, down, up, so more belief in help. But as you can see, the most common answer of all is that it would have no impact on any of this. And that's true for respondents' assessments of themselves. Almost 60% of respondents said, yeah, I favor doing this, but not because it will affect me. It's not going to make my life better or worse. But among those who think they will be affected, about twice as many, 27% here, believe their lives will be made better by prevention efforts, and only 13% believe that they will be made worse. Now, I'm going to show you a regression. So this is a statistical analysis predicting who takes the more positive perspectives on prevention efforts. And what we're predicting is an index that's a combination of these three opinions. First, that sea level rise is a threat. Secondly, that storms are a threat. And thirdly, that preparation is a good idea. So what this regression shows you here, if you look on the right-hand side, is that looking at the top three rows, that the positive number here in these rows means more positive impact on the state economy and local economies lead to more support for preparation, more concern about harm, reduces support for preparation. And the important point here for you to see is that there is no asterisk next to this 0.06. What that means is that people are not thinking about these preparation efforts in terms of the national economy. They're only thinking about them in terms of their state and local economies. And you can see that the largest coefficient here is for impact on the respondent, him or herself. So the individuals who believe they will be helped are more likely to favor these efforts. Those who think they will be hurt are less likely to favor these efforts. But in addition, the proportion of the respondent's state population that's in a coastal county also has impact. That is, in addition to themselves, folks whose states are going to be affected are more supportive of taking preventive action. Now, as you can see, however, this, the next line here, this 0.07 without an asterisk, means that individuals who themselves live right by the coast are not particularly inclined to be supportive or unsupportive. There's no impact of that directly, but not surprisingly, people who trust climate scientists more are more supportive of preparation efforts. People who believe that global warming has been happening are more supportive of such efforts. Democrats are more supportive, and Republicans are less supportive. So these numbers make sense both from a rational perspective and from a political perspective. Okay, so that brings us to the end of part one. Part two. Specific preparation strategies. In the public opinion literature, we have lots of evidence that Americans sometimes embrace a principle, but then they decline to embrace the implementation strategies that could be used to bring it about. So yeah, in principle, I would like the federal budget reduced. But when you talk about reducing spending in various areas, people don't like reducing spending in those areas. So it's hard to find a way to implement the principle. So let's look at whether that shows up here as well. The strategies that we looked at are, first of all, building what are called seawalls, walls of steel, rocks, or cement along the shore to block sea level rise and surges from causing damage. Secondly, adding sand to beaches after sand is washed away to replenish the sand to resist the decline of the beach. Third, putting large mounds of sand and plants called sand dunes along the shore. By the way, I'm showing you the language we used in the survey to describe these strategies to respondents. These three I think of as the strategies for resisting Mother Nature, trying to keep the water back. Another possibility is moving the people back, and so that's this fourth one, offering money to people or businesses near the coast to move away. And then we have a series of regulations or laws, first of all, to reduce building new buildings near the coast and reduce risk that way. Secondly, to implement new building codes to reduce damage to new buildings. And thirdly, to prevent replacement of buildings that are damaged by sea level rise and surges along the coast. So we'll look at support for each of these strategies, but first let me just point out this portion of the survey is done in the spirit of survey research that falls under the heading of what's called contingent valuation. So here we took for granted the idea that many respondents would not be familiar with these policy options. So we took steps to educate them a bit about those options by telling them about some of the most prominently discussed advantages and disadvantages of each policy, and in cases where the government would spend money to give them a feel for the cost of the policy. And in some cases we showed them photographs. So let me give you an example here. So this is a pair of photographs of a spot along the beach. The first one on the left without a seawall, and the second one, as you can see right here, the seawall was built in this place. Seawalls can be built in lots of different ways. This was a way of showing them one example of this. Here's sand replenishment. So this is the same location on the beach. You can see that the water hits this building in the middle of the building, and after sand has been added to the beach, the water hits further out at the same time. Lastly, this is building a sand dune. So here's a set of buildings with sand removed, and then the sand dune with plants put in front of it. This is the photograph that we showed people to give them one example of how building codes could be changed to require that new buildings built along the shore might be put up on stilts instead of being down on ground level. Okay, so let's look at the proportions of Americans favoring or opposing various policies. So as it turns out, the least popular approaches include fighting Mother Nature. Only 33% of people favored replenishing sand that's been washed away. Only 33% favor building seawalls to hold the water back. Moving the people back by offering them money, not much more popular. Only 37% of people find that appealing. A bit more support for prohibiting rebuilding damaged buildings along the coast at risk, 47%. We're not quite up to the majority of Americans yet. Building sand dunes is at 49%, favoring it, almost there. But the policies that people like the most are not trying to deal with the past as much as dealing with the future. So first of all, reducing new building along the coasts and requiring new building codes to prevent buildings to be put in place that would be at high risk. So as you can see, there are only, of this set of policies, 2 of them that even achieve 50% approval. And these are policies that will not solve problems for existing buildings. They look forward to new building. Now, who should pay if the government were to build seawalls or put in sand or sand dunes? We asked people about 2 options, and you can see an overwhelming preference. So we asked about seawalls, sand replenishment, sand dunes, and managed retreat, and overwhelmingly, about 80% of people said that there should be increases in property taxes for coastal property owners to pay for all of these strategies. So it should not be that all Americans are paying for those folks who are at risk. These 15% to 18% here at the bottom, we haven't had a chance to look yet, but one might imagine many of those are folks living right by the coast. Okay, this brings us to part 3. So what we've seen so far are 2 things. There appears to be widespread acceptance of the existence and risk of sea level rise and storms. Secondly, there is a clear sense that people would like to take preventive action. They would like the individuals at risk to be paying for that action. There are some strategies that they like, others that they don't, and mostly they're looking forward. Now, this is a story of science communication. This is a story of natural scientists disseminating their work, partly through the news media, to the public about all of these findings. And when natural scientists talk about their work, they have a number of choices about how to do it. In fact, we'll focus on 3 options. One is they can talk about potential sea level rise in the future, let's say, without mentioning at all the uncertainty that's inherent in their research findings. So they could say, our best guess is the following. But there's an increasing sensitivity now among natural scientists to the question of whether it's ethical to do that. There are some arguments that can be made that it is, in fact, the ethically desirable thing. But on the contrary, others sometimes argue that the ethically proper thing to do is to acknowledge the uncertainty that scientific research has with it. And one way to do so is to prevent misleading people into too rosy of a picture by saying, well, there is also a worst case possibility. So our best guess is this could happen, but it could also be as bad as that. And especially folks in the insurance industry are especially interested in that worst case scenario because they often say they would like to guard against that in order to remain solvent. But there's a third option as well, which is for a scientist to acknowledge the full range of his or her uncertainty about a particular topic, so they can talk about their best guess, but they can say, however, the damage could also be as much as this, and it could be as little as that. That's a full confession in a sense. So now what I'm going to do is step aside just for a second and welcome Lauren Howe to the podium, who is a graduate student at Stanford and working on this project, so she can give you a sense of what the literature tells us about how confessing uncertainty like that might impact how the public thinks.
Hi, so as John said, I'm going to outline some of the background that inspired us to explore scientists expressing uncertainty about their findings, as well as the rationale behind our hypotheses of what the consequences of expressing this uncertainty might be. So communicating uncertainty is particularly important to climate change research because it is a complex science involving probabilistic results and thus somewhat inherently uncertain. So climate scientists attempt to predict future outcomes, and these predictions are based on a variety of assumptions that the climate scientists must make. So to illustrate how uncertainty plays an important role in discussions of these outcomes, I'd like you to take a look at this chart over here, which shows one research team's proposals of how human activity could contribute to climate change and the expected outcomes that would result from this human activity. But as you can see in this chart showing different scenarios, different models of human activity make different predictions about the changes in emissions that would occur in a way that make all of these outcomes more uncertain and all of these estimates more uncertain. So along with this, there are many sources of significant uncertainty in climate change research produced by natural scientists studying climate change. So the sources of uncertainty in climate change research can be categorized into three different types. First, there is epistemic uncertainty, or uncertainty that results from a lack of complete knowledge about a topic. So you can imagine this uncertainty being reducible by conducting more and more research, so you can imagine it ultimately being resolvable. There's also the problem of ambiguity, or that scientists from different backgrounds might interpret results differently or take different approaches. But you could imagine this being reducible by increasing communication among scientists and having different groups be very open and transparent about the different approaches that they're taking. So you can imagine this ultimately being resolved. And the final kind of uncertainty is aleatory uncertainty, or uncertainty that's due to inherent variability, natural uncertainty, which leads to several different possible outcomes and conclusions, and thus cannot be completely reduced. So this kind of uncertainty is inherent in climate change research, and climate scientists might be understandably concerned about this uncertainty because of its potential impacts on the public's view of their work. So the public might only be thinking about the first kind of uncertainty, epistemic uncertainty, and thus be confused about why climate scientists cannot definitively say what will happen. People might think that all problems should be solvable by research, so if scientists are uncertain, they should go and do more work to help eliminate that uncertainty. But in climate change science, achieving complete certainty is almost certainly impossible. So the question is, what will happen if scientists are fully honest with the public about their uncertainty when making predictions? So one possible outcome is that the public might respond with a wait-and-see approach. The public might conclude that the facts are not all in and may want to wait until scientists can provide definitive conclusions before acting to deal with climate change. This is just what the tobacco industry sought to accomplish several years ago, to convince the public that medical science about the health risks of smoking was not yet definitive, so no one should act on the assumption that smoking was dangerous. Or if natural scientists express uncertainty, this might make them seem weak in the eyes of climate change skeptics who may be motivated to deny the existence or threat of climate change. And third, natural scientists expressing uncertainty might just be too confusing for the general public to understand. So some people struggle with the idea that scientists can reach conclusions while still disagreeing amongst themselves. And people might not understand the difference between the implications of a single study, a handful of studies, and broader scientific consensus based off of many studies. So for all of these reasons, natural scientists might be tempted not to acknowledge their uncertainty publicly, as seen in the IPCC's decision not to include the melting of ice sheets in the Antarctic and Greenland in their 2007 report's quantitative projections, because they could not provide a single best estimate of what would happen. But you might start to wonder if withholding information about uncertainty is unethical. So perhaps natural scientists have the need to talk straight with the public. It's part of the role of a scientist to interpret data for the public, and climate change scientists may need to achieve a delicate balance between communicating effectively with an audience about what they need to know and being completely honest and transparent about their results. There's also some evidence suggesting that acknowledging uncertainty might not only be the most ethical thing to do, but might in fact enhance confidence in scientists and their messages. So when people see science as a debate rather than a search for the absolute truth, uncertain messages actually are more persuasive. So you could imagine that expressing uncertainty might help to engage the public in a dialogue with scientists and help to increase trust in and foster understanding of the scientific process. And explaining the particular kind of uncertainty that climate scientists face might actually eliminate any negative impacts of uncertainty. So similarly, it may also be very important for policymakers to understand not only science's best guesses, but also the full range of possible futures that we might encounter. So here's just one example of how scientists have begun to communicate the full range of possibilities with the public, taken from UK climate projections. So scientists will give people not only their best estimate of what might happen, but worst case scenarios, and also best case scenarios. So now the remaining question is how the effects of this honesty will impact public thinking. And so now John's going to tell you a little bit about how we've begun to approach these questions. Thanks.
Thank you, Lauren. Okay, so we've talked now about what I've described to you, the three options that natural scientists have to keep their uncertainty private, to describe the worst case scenario in addition to their best guess, or to describe both the worst and the best cases in addition. So in this particular experiment, we're looking at two different types of uncertainty. The first is how much sea level rise will occur in the future, and we'll describe to some of our respondents scientists' best guess, some what we'll call their best guess plus a high tail meaning the worst case, and some being told about best guess plus the worst case and the best case, the high tail and the low tail. And we'll talk about uncertainty with regard to storms. So the research questions that we'll be asking follow directly from what Lauren described, and they are as follows. Does mentioning a high tail, that is the worst case, increase perceived threat? Secondly, does mentioning a low tail, the best possible case, offer people an opportunity for denial? So if I tell you, well, most likely sea level rise will be 4 feet, but it could be as little as 1 foot. You might say, ooh, that sounds good, 1 foot, I'll take that. And therefore, it's an opportunity to ignore more serious news. Does mentioning both tails, the worst case and the best case, in addition to the best guess, reduce trust? As Lauren said, does the public say, look, you sort this out, figure out what the right answer is, and get back to me when you know? Or is it possible that, as she suggested, telling people about the range of uncertainty is a way to increase trust in scientists? Because if I tell you there will be 4 feet of sea level rise 100 years from now, it would be natural for you to say, come on, you don't know that exactly, right? And if I say to you, well, you're right, I don't know it exactly, but I know it within the following range, that might actually enhance trust. Does mentioning storms reduce trust? And so here the idea is that if sea level is rising and storms will bring about added damage, as we saw Superstorm Sandy do in New York, will that actually reduce trust in scientists? Because the fact is they can only talk about storms uncertainly. They cannot predict when, where, and how severe those storms will be. Or does mentioning storms increase trust? Because again, it fully confesses the uncertainty of the impacts. So here's how we tested this in this survey. Each respondent was randomly assigned to be put in one of the 6 boxes in this chart. So either we told them only about scientists' best guess about the fact that sea level rise would be about 4 feet over the next 100 years, or we told them scientists believe sea level rise will be about 4 feet, but it could be as much as 7 feet, or we told them scientists believe it will be 4 feet, it could be as much as 7, or it could be as little as 1. In addition, we randomly assigned people to be in one of these two columns. Either we told them, and storms may add to the effects of the sea level rise by producing surges, or we did not mention storms. So we'll look at the impact of all these communication efforts. Let me quickly walk you through this. This is an example of the text that the folks who were just told about the best guess read. So it says, scientists believe that during the next 100 years, global warming will cause the surface of the oceans around the world to rise about 4 feet. That's the best guess. In the United States, sea level rise will mostly affect towns and cities along the coasts, where millions of people live and work. Sea level rise will gradually flood these areas, so people living and working along the coast will have to move their homes and businesses to other places, farther from the ocean. And if the sea level rises by 4 feet and nothing is done to prepare for it, about 5 million Americans who currently live and work less than 4 feet above sea level will have to move out of their homes and businesses. Now, these numbers, by the way, are not wild guesses we came up with. These are the result of extensive consultation with experts who study sea level rise and displacement. Now, the folks who were in the best guess plus high tail condition saw exactly the same language plus these two sentences. However, sea level could rise by as much as 7 feet. And here what it says is that if sea level does rise by 7 feet, about 8 million Americans who currently live there will be displaced. Here's the best guess plus both tails, the full confession of uncertainty, where we add or sea level could rise by as little as 1 foot. And if it does rise by 1 foot, 1 million Americans will be displaced. Let me now read to you the storm surge language that half of the respondents read. This rise in sea level will make hurricanes, cyclones, and other storms worse for people living and working near the coast. Scientists believe that global warming will cause these storms to be more intense in the future. During these storms, oceans will surge as high as 20 feet along hundreds of miles of coastline and will suddenly flood cities with large amounts of water. These floods will be more damaging over the years as sea level rises, and floods will be even worse when storms hit during high tide. For example, Hurricane Sandy caused ocean surges as high as 14 feet and flooded tunnels, bridges, and other parts of New York and New Jersey. Now, when you look at this language, you can imagine a natural scientist saying this, but you can also imagine NGO organizations interested in fully educating the public about what they believe to be the risks to describe potential effects in this language. So what this experiment does is to look at what impact these kinds of messages have on how the public reacts, and it turns out they do have impact. So the first question is, how familiar are people with these messages? Do they remember hearing or reading scientific statements like this? And what I'll show you, first of all, is that about 67% of people said they thought they remembered hearing a message, something like the best guess message, that sea level will rise about 4 feet over the next 100 years. So that's a fairly hefty number. It's nowhere near 100%. For those people in this room or elsewhere who think, how could people not have heard scientists or someone talking about sea level rise? Well, that message sounds familiar to only about 2/3 of Americans. What happens when we add uncertainty to that? When the scientist says, well, it could be as bad as this, could be as good as this. Turns out familiarity goes down. So fewer people, 54% in both of these conditions, say that sounds familiar. What they say is, geez, I don't remember hearing about this kind of range of uncertainty. Secondly, among the people who did not see the storm message, about 50% of them on average said that they remembered hearing or reading something like that, but the storm message is itself much more familiar. About 2/3 of Americans remember hearing statements like this about climate change causing surges and storms. So when we put all of this together, what you can see is these first two bars, that the best guess is more familiar to people than the best guess accompanied by uncertainty. And when adding this, just the storm statement itself, we get up to 3/4 of Americans saying, I think I've heard something about that. And again, when we add uncertainty, they say, I don't remember hearing about that uncertainty. So now, what impact do these messages have on perceptions of threat and attitudes toward preparation? So first, we're going to look at the results on the surface. And when we do it on the surface, it looks like none of this matters, but it turns out underneath the surface, there's a very interesting pattern. So for the people who were only told about the best guess, we created an index, again, of how supportive they were of preparation policies and how much threat they saw from global warming-induced sea level rise and storms. 57% of people, people ended up at a 57% score on average when they were only told the best guess, and the numbers are almost exactly the same when the scientists express uncertainty. So it's not the case that describing the worst case pulls up support for mitigation, for preparation, and it's not the case that describing complete uncertainty leads people to back off. But I'll show you in a moment, things are more complicated. What happens when we add the storm message to people's communication? Well, the people who did not hear about the storm score at 55% on this index, and again, almost exactly the same score when you describe storms to them first. So it looks as if telling them about the risks of extreme weather does nothing to change their opinions about the need for preparation. But actually, here's the real pattern that's happening underneath. So let's focus only on the people to start with who've not been told about storms. And we're going to compare two groups, the people who are only told about the best guess to those who are told about the worst possible scenario as well. And here what you see is no impact. So saying probably 4 feet, could be as bad as 7, doesn't do anything. But when you now move from could be as bad as 7 to could be as bad as 7 and could be as little as 1, now you can make a little prediction in your own mind. When we offer them could be as good as 1, are they going to say, great, that's good news, I'm now less concerned? Or does acknowledging that full uncertainty lead to greater endorsement of scientific perspectives? And the answer is it actually increases concern. So in this case, full confession of uncertainty by a scientist increases acceptance of the scientific message and the step toward prevention. Now, what does adding storms do? Well, we're going to focus here, first of all, on the people who only read the best guess about sea level rise. And now when we add the description of the storm to it, we see the score 52% for people who did not see the storm message, and a very large rise of up to 62% who hear about the increased risk associated with storms. So this would be evidence consistent with the perspectives that some people express, that in order to whip up public concern, talking about the risk of storms is a good idea. However, under the conditions of scientific uncertainty, when people are describing the worst case scenario possible, in addition to the best guess, adding the storm does the same thing. It increases concern, but under the conditions where scientists fully confess their uncertainty and don't talk about storms, this is the proportion of people scoring, they have 59% score on average. When the storm is added to it, there is a statistically significant drop. So this is the important point of this segment of the talk right here. What it says is if scientists fully confess their uncertainty to the public, and that is accompanied by a message exacerbating the uncertainty even further, saying there will be storms, they will make things worse, we don't know when they'll happen, we don't know where they'll happen, we don't know how serious they'll be, people actually back off. And this is consistent with a lot of research in psychology suggesting over the years that, for example, if you want to inspire people to take steps to protect their own health, you want to induce a little bit of concern, but you don't want to overdo it. You don't want to create a severe sense of fear, because in that case, psychodefenses kick in. So it's an interesting idea here for those communicating with the public who think that communicating all the risk, it could be as much as 7 feet and then it could be another 15, is a good idea. Well, at least in this study, it suggests that expressing all of that might actually reduce acceptance of the point of view. So let me just show you these same bars all together. So expressing only partial uncertainty with no storm message is less persuasive than expressing full uncertainty by the scientists, and this is exactly the same thing I showed you a moment ago, where when scientists move to express their uncertainty in the presence of a storm, the storm actually, it backfires at that high level. Okay, so these bars all put together now will show you the following. That as long as scientists are not fully honest about their uncertainty, talking about storms and extreme weather publicly yields the highest levels of support for prevention efforts. But if scientists are confessing their uncertainty, levels of public support are the same as if people had never heard about the storm in the first place. Okay. So, conclusions. Full acknowledgement of uncertainty increases acceptance of scientific positions. Mentioning of storms increases acceptance as well, but mentioning storms in the presence of full acknowledgement of uncertainty is overwhelming and reduces acceptance. So why does this happen? Why is it that telling people, I don't completely know, actually leads them to be more supportive of the message? Well, one hypothesis that Lauren put forth is that it may increase trust in scientists. That is, scientists who pretend to know about the future exactly may seem less credible and believable than scientists who confess their uncertainty. So we actually measured this in the survey. We asked people, how much do you trust the things that scientists who study the environment say? And I want to show you the results are remarkable. They look exactly like the results I showed you a moment ago. So this is the proportion of people who report high trust in scientists. And you can see that when the scientists do not fully confess their uncertainty, these numbers are about 70%. A statistically significant increase happens when the scientists confess their uncertainty without talking about storms. When they're talking about storms and no uncertainty, these numbers are high. But the minute they say, well, here's the possible range of sea level rise, and there can be storms, but we don't know when, we don't know where, we don't know how serious, trust goes back down, in fact, to the lowest level. So honesty, in terms of the scientists, seems to be a way of building trust as well. Okay. So, conclusions overall. Most Americans appear to support preparation efforts rather than waiting and seeing. There's little support for trying to fight Mother Nature by holding the water back on existing coasts. There's the most support for forward-looking policies that restrict building and strengthen new building along the coast. There's a clear sense in which coastal dwelling businesses and individuals should pay the cost. This is not a set of policies that the country as a whole is interested in paying. And we saw that if scientists confess their uncertainty, this increases trust in them and acceptance of their messages. But when faced with fully honest expressions of uncertainty and a focus on unpredictable extreme weather, people appear to shut down. So I hope that during this presentation you've gotten a sense both of a little bit of insight into how the public thinks about adaptation efforts. Certainly this is the first in a series of studies. It opens up as many questions as it does resolve them. And so we look forward to doing more work, but I'm also happy to answer questions for you if you like. Thank you.
Hi, I'm Mark Wensler with the National Parks Conservation Association. I'm interested in your contingent valuation portion of your study when you talked about seawalls versus dunes. Did you also talk about sort of the multiple values of dunes in terms of wildlife habitat, scenic value, recreational values? Because it occurs to me that seawall has one value, stopping water, whereas the dunes have multiple values.
Yes. Well, we talked in each case exactly about the advantages and disadvantages, and mentioning that sand dunes would become habitats for wildlife was one of the advantages that we mentioned.
Thank you.
Thank you. Seth's got the, Seth's got the mic. Go right ahead, Seth, please.
Seth Bornstein, AP. Just in general, you talked about mentioning costs, but did you give any sense of the amount of costs, especially with something like a seawall for a city like New York, where you're talking a large amount of money as opposed to just the seawall at someplace in North Carolina in front of someone's house? And the other is, did you look at other climate change impacts and costs of adaptation and preparation, such as with heat waves or things that would not affect coastal persons? And was there a difference? I mean, is this just, well, if you're rich enough to have a house on the coast, you can pay for it yourself, but when it comes and hits me in central Missouri, I want help?
Yeah. Well, so first, I'm very glad you asked the second question, because that sets up our future research, which we have not done yet, but we look forward to doing it. Thank you for asking. The powers that be heard you, I'm sure. Secondly, in your first question, yes, we did actually describe specific dollar amounts, which are remarkably high for building seawalls, for example. So the reluctance to build seawalls may very well be a reflection of people's reluctance to pay a very high cost for them.
What were the dollar amounts?
We can get those to you, and we will be happy to. All the way in the back there. Rob, can you do that, just to be geographically fair?
I'm just wondering if you can mention sample size and the regions that were sampled.
Thank you. So the sample size I described to you on an early slide, it's about 1,200 people. And bear in mind, this is what's called a random probability sample of the country. So it reflects the country almost exactly in terms of the proportions of people in every region, the proportions of people in every education group, every age group, every gender and race, and so on. And so though there are discrepancies on those factors, including region, but we also implement what's called a statistical weighting procedure to adjust the sample so that it exactly matches the country in terms of all those factors. So when we're looking at the fact that people along the coast are more supportive of these prevention efforts than people who are farther away, that's a random sample of coast people as compared to a random sample of people who are elsewhere in the country. Do somebody here?
Neela Banerjee with the Los Angeles Times. I wanted to go explore the issue of scientists and various and acknowledgments of probabilities. It seems like there's a fairly fine line that they have to walk, that if they give too much information, it's problematic. I mean, am I understanding that correctly? Because it's not just the acknowledgement of what would happen with one phenomenon, which is sea level rise, but when you bring in something else like a storm or a storm surge. So if and I see you nodding your head, so I'm assuming that I'm understanding that correctly. So if that's the case, then say, if we're talking about sea level rise and there's a storm coming akin to Sandy, I remember one of the things in watching reactions to Sandy was that people were saying, oh, the media, the scientists, they're hyping it. And as it turned out, what happened with Sandy, based on the scientists I spoke to, it was very accurate. How should scientists frame something if you have the unpredictability of a storm coming in when you're already dealing with sea level rise?
Thank you so much.
Care to fashion a script in
Yes,
front of us?
I really appreciate your asking that question. Actually, you can give it to Wendy in front of you if you want. Because I'm happy to be really clear about this. I am not here today to make any recommendations to scientists about how they should communicate, or any recommendations to the news media about how they should communicate, or any recommendations to NGOs about how they should communicate. My role and my team's role is simply to study the impact that different ways of communicating have on thinking. So I don't personally make a value judgment about the idea that high scores on support for preparation efforts is a good thing or a bad thing. That's for somebody else to decide. But for me, what I can describe is that if scientists, for example, on ethical grounds, decide to fully confess their uncertainty, and if a hurricane like Sandy is coming, and if the message gets out to the public that this is most likely caused by climate change, that may well cause this backfire, what people would perceive to be a backfire, in public concern about it. And if you're intrigued by this, I will tell you that this afternoon, the Capitol Hill briefing that we're doing, sponsored by EESI, will describe new research on the impact of Hurricane Sandy on public opinion. And that will show you results very much in line with this, showing you the actual, so this is an experiment I've told you about this morning, but that's actually tracking over time how the public reacted to that storm. And there are some very interesting, surprising findings there as well. Wendy.
Wendy Koch, USA Today. John, I wanted to ask you if this is kind of a benchmark survey on public attitudes towards climate adaptation. And if not, how do these findings compare to earlier ones? Is the public more accepting?
Yeah, thank you. And we should have made that clear. As far as any of us know, this is the first serious in-depth study of public opinion on adaptation and prevention efforts that's been done. And so it is an increasingly interesting topic, particularly in the wake of Sandy. But really, it was Meg's idea to do this, and to go into depth. This was the first step in this direction. So I guess, yeah, benchmark is a good word for it. Maybe we'll repeat it. Chris, you can give it to somebody.
Hi, I'm Christina DiConsini with the World Resources Institute. I'm familiar with a recent focus group that some polling done in Florida, and I know you can't do apples and oranges, and it wasn't about preparedness and adaptation. It was about sea level rise, and sample groups were people who were thought to be not super likely to be climate change champions, and that showed that again and again, when you showed the range, and they didn't talk about storm, if you said the sea level rise from these maps that we have here between 1 and 6 feet, that again and again people actually thought they would actually say, well, you obviously don't know what you're talking about if you think it's between 1 and 6 feet. So they just sort of like dismissed it. So I just think that's interesting because it didn't have the storm piece in it.
Yes, so we actually thought very much about exactly that hypothesis. The idea that among climate change skeptics, confessing uncertainty might lead them to back away. Now, bear in mind, climate change skeptics have pretty much already backed away, right? They're not endorsing much of anything. And so the idea that scientists confessing uncertainty, they'd say, yep, I knew that all along. I knew they didn't know what they're talking about. They've now confessed that they don't know what they're talking about. We imagined that could happen, and we designed the survey to look for it, and we didn't see it. So the question is, well, why didn't we see it when it was seen in focus groups in Florida? And one hypothesis is, for any of you who've either been in a focus group or seen one, they are a group dynamic. If you bring a group of people who are climate change skeptics together in a room and they kind of learn that about each other, you can imagine in the focus groups I've run over time, that starts to resonate. That starts to become like a group mission for the conversation. Our survey is not that. Our survey is each individual climate change skeptic in his or her own home answering questions privately, not being revved up by others potentially. So focus groups may be very useful for looking at how opinions are formed and changed in a social context, but ours may be a bit more suited for individual measurement of existing opinions.
Talia Buford, Politico. Just have actually a quick clarification question. Can you explain again what exactly you mean by coastal communities? How far are we talking in? And also the briefing today, what time will that be, and who exactly will you be speaking to?
I have no idea who will be coming. It's open to the public. It's on Capitol Hill, and it's listed on the EESI website. When we talk about the idea of coastal dwellers, these are people who live in counties right along the coast. So counties, you could think of it as either big or small, but that's the unit that we used. And actually, thanks to Adina Ablis's remarkable work in conjunction with NOAA, we were able to assemble a very big data set. As you can imagine, you take 1,200 survey respondents, each of whom have a zip code, and you've got to map those zip codes to figure out who lives right by the coast. That's a lot of work, and it was done very quickly this month.
So stepping out from behind the pillar here. So Chris Pike, U.S. Green Building Council, and the capacity I write for IPCC for the U.S. And quick question I have about two words you keep using, kind of using the word confess and this notion of honest, if we're honest. I don't think either word resonates with me, and it's kind of a repeated narrative here about the notion that scientists are somehow being implicitly dishonest when they're actually struggling to communicate at this point, particularly in translation through the media. Can you reflect on, you clearly are anchored on those words and the implications of those words?
Thanks for pointing that out. I guess I don't mean to say anything other than what I've been hearing in discussions this last year at Princeton University. The Princeton University Woodrow Wilson School, Public Policy School, has a remarkable group of scholars who are studying uncertainty in the arena of climate change in many ways. The uncertainty of the public, uncertainty of the scientists, uncertainty of the policymakers, and I'm fortunate enough to have been invited to be a part of that group and have been involved in quite a few conversations with them. An important chunk of that group are concerned with the ethics of scientific communication. So to the extent that my language describes the idea of confessing uncertainty as opposed to revealing uncertainty or acknowledging uncertainty, I didn't mean to give it an editorial spin, but I will tell you it's a result of my listening to those discussions and I guess the perspective that I've taken from them. But I'm more than happy to say, if you would rather put a different word on it, please feel free. What I really mean to refer to is just describing that uncertainty.
Emily Seiler with the U.S. Global Change Research Program. Did your study look into the use of visualization tools at all, along with the text that you're using to describe the uncertainties?
Yeah, that's a great question. So when we ask people about policies, such as building seawalls, we could have allowed them to visualize it on their own. In fact, an extreme version would be imagine the entire country with walls around it, like we saw after airports, in front of airports after September 11th, for example. Or maybe much taller seawalls around the entire country, or around populated areas. And our concern was that if we allowed people to visualize it on their own, they might be imagining unrealistic scenarios. So we decided that we would provide these photographs. Now, the photographs are themselves editorial choices, right? There are many different photographs that we looked at and considered. And ideally what we'd like to do is to have a budget and a schedule where we could zip around the country on very expensive aircraft and take pictures of lots of seawalls in different places, both before they were put in place and afterwards. Not at all possible. So the question then is it better or worse to prevent that visualization or imagination process? In this particular study, we made the choice to provide photographs. But one could argue that it would actually be better to induce people to visualize the country with seawalls however they wish, or in ways that we couldn't get photographs for, or to use different photographs to see the impact that they have. And so that would be a direction for future study. One more question. Whoever's got the mic.
Anna Unruh Cohen. I'm with the House Natural Resources Committee, Democratic staff, and I wondered if in your work you were able, especially at the end, putting together the sea level rise and storm surges, if you got a sense that people perceived those two phenomenon differently, that at least people's experience of sea level rise is more gradual, even if it has been increasing, whereas storms are a much more chaotic, random event, and whether that influenced how you saw people reacting to the combination of the two.
Yeah, well, now that we have seen what these results look like, it introduces exactly that kind of question. And so the next study we would do in the sequence, now me speaking as a psychologist, would be to try to get into people's heads. I will tell you that when we began this investigation of the impact of communicating uncertainty, we, as you could see from Lauren's review, had lots of possibilities we saw as ways the data could flow. And we had enough other agendas in the survey that we didn't have room to put in all those measures we'd like. But now that we've seen the pattern, we do want to repeat it. We want to try to understand, is it the chaos and unpredictability of the storms, or is it the greater threat of the storms? Is it that people see sea level rise as a gentle, gradual, sure, there's plenty of time to sell your house and move and get back. And each of those and other hypotheses as well are interesting ones to try to get at, because if someone is designing a communication strategy, one would want to know what the mechanisms of these effects are. Thank you.